Assalamualaikum and salam sejahtera. Today, my partner and I will be presenting our project on the Highland Tower collapse, specifically through the lens of HIREC analysis, which stands for Hazard Identification, Risk Assessment, and Risk Control. This case is one of the most well-known engineering disaster in Malaysia. It not only cost many lives but also served as a valuable lesson for the importance of proper risk assessment and safety management in construction projects. My name is Nurul Fahana binti Azwanri and my partner name is Nurul Amalina binti New Zealand. Before we discuss the incident itself, let me briefly explain what risk assessment is. Risk assessment is a structured process used to identify hazard, analyze the risk of level, and implement control to reduce those risks. This HIREC framework is one of the most widely used approaches, and it consists of three main elements. The first one is hazard identification, spotting anything that could cause harm. The second is risk assessment, that is evaluating likelihood and severity of harm. The third one is the risk control, applying measures to eliminate or reduce risk. This process is crucial because it prevents accidents, protects human life, and ensures engineering practices are safe and sustainable. In the case of Highland Tower, the absence of effective risk assessment was a key factor that contributed to the disaster. Now, let us look at the background of the incident. On 11 December 1993, in Ampang, Selangor, Block 1 of Highland Tower collapsed after experiencing several days of heavy and continuous rainfall. The collapse tragically claimed the life of 48 people. Investigation revealed that the slope behind the building failed and the retaining wall that was supposed to support it also gave way. This sudden structural failure caused the entire block to come crashing down within seconds. The Highland Tower disaster shocked the nation and highlighted serious weaknesses in hillside construction practices during that time. Let us now examine the root cause of the collapse. Firstly, heavy rainfall was a significant trigger. The intense downpour led to soil saturation, which made the slope unstable. Secondly, there was a poor drainage system, which failed to channel away rainwater effectively. Instead, water seeped to the soil, adding weight and pressure. Thirdly, the retaining wall itself was poorly designed and not strong enough to withstand the additional load. Additionally, the construction of housing project at the hilltop increased the soil load, further worsening the pressure of the slope. Lastly, there was a lack of regular inspection and enforcement by authorities, which allowed unsafe conditions to persist until the disaster happened. In short, it was not just one cause, but a combination of engineering, environmental, and administrative failures. Alright, today I will present a HIREC analysis for the Highland Tower collapse. Firstly, a slope retaining wall. The retaining wall was weak and caused landslide, which the level was extreme. So, control a straightened wall, slope stabilization, and inspections. For the second, hilltop construction can a clearing land make a slope unstable, risk wall height, so control limit excavation and monitor hillside closely. Third, drainage system. Drainage system for draining a caused water buildup and a soil weakness, risk of water extreme, so control can upgrade drainage and do regular maintenance. For the fourth, building structure, contract and a weak foundation increase collapse risk of wall height, so control improve foundation, is the sensors and audit regularly. For the lastly, emergency preparedness. No evacuation plan or warning system. People are trapped during collapse, so control make evacuation plan and conduct safety drill. Okay, so for the findings, we have 3 points. The first point is hazards. For the hazards were actually foreseeable and preventable. There are warning signs such as soil movement and water seepage were already visible before the collapse. Point 2. Risk levels. The secondary risk level was classified as to extreme. This means the chance of failure were significant and the potential consequences were very severe, including loss of life and property. Okay, the last point is a main failure. Finally, the main failure was the lack of proper engineering and administrative controls. There were no effective slope stabilizations, drainage systems, or strict monitoring to ensure safety. Okay, for recommendations, firstly, engineering controls. First, we need engineering controls. This includes slope stabilizations, contracting, proper retaining wall, and ensuring effective drainage system to manage rainwater. Second, administrative controls. Administrative controls are very important. Authorities must enforce strict hillside contractation regulations and conduct regular inspections to ensure compliance. Third, emergency preparedness. Emergency preparedness should be strengthened. This means conducting a drill, having evacuation plan, and using early warning system to alert residents of potential dangers. Lastly, long-term measures. And finally, for the long term, the best solution is to avoid building in high-risk hillside areas altogether. Alright, for conclusion, point 1, importance of HIRAS. The collapse clearly show the importance of HIRAS, which means hazard identification, risk assignment, and risk control. If the process has been applied effectively, the disaster could have been avoided. Point 2, a safety culture. A stronger safety culture with proper monitoring and preventive action could have saved many lives. Point 3, key lesson. The key lesson here is that in engineering and construction, safety must always come before profit. So, cutting corners on safety can lead to irreversible losses.